Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra, chapter minimal polynomial and minimal equation of a matrix, lecture number 5, in which I will prove an important theorem. Theorem is the minimal polynomial of an n by n matrix A is minus 1 to the power n determinant of A minus lambda I divided by G lambda, where the monic polynomial G lambda is the HCF of the minors of order n minus 1 in determinant of A minus lambda I. Now we prove this. Since a minor of a matrix A is the determinant of a square submatrix of matrix A, given that the monic polynomial G lambda is the HCF of the minors of order n minus 1 of matrix A minus lambda I. Therefore, G lambda is a divisor of all n minus 1 root minus of matrix A minus lambda I. Since determinant of A minus lambda I is a linear combination of minors of any row of A minus lambda I matrix. Therefore, G lambda divides determinant of A minus lambda I, implies that determinant of A minus lambda I equal to minus 1 to the power n G lambda multiply H lambda, where H lambda is a monic polynomial. This is number 1. Since each element of adjoint of A minus lambda I is numerically equal to some n minus 1 root minor of A minus lambda I matrix. Therefore, G lambda divides all elements of adjoint A minus lambda I, because G lambda divide n minus 1 road minus of A minus lambda I. Therefore, adjoint A minus lambda I equal to G lambda multiply B lambda. Let this is number 2, where B lambda is n by n matrix such that its elements are polynomials in lambda having no factor in common, pre-multiplying both sides of 2 by A minus lambda I, we get A minus lambda I multiply adjoint of matrix A minus lambda I equal to G lambda matrix A minus lambda I B lambda. Since A adjoint A means determinant A multiply unit matrix, here determinant of A minus lambda I unit matrix equal to G lambda multiply A minus lambda I B lambda. Since A adjoint A equal to determinant of A unit matrix I, by using 1 we get here minus 1 to the power n G lambda H lambda and unit matrix I equal to G lambda A minus lambda I B lambda. Since G lambda is a non-zero monic polynomial, therefore we may cancel from both sides, implies that minus 1 to the power n H lambda I equal to A minus lambda I B lambda. Since G lambda not equal to 0. This is number 3. By putting lambda equal to A in A minus lambda I, we get A minus lambda I equal to A minus, in place of lambda we write AI equal to A minus A equal to 0 matrix. This is number 4. replacing lambda by a in theory, and then using 4 we get minus 1 to the power n h a I equal to, this is zero matrix. Zero matrix multiply b lambda is zero matrix. Implies that H A equal to zero matrix. This is number 5. Therefore, the monic polynomial H lambda annihilates the matrix A. Let m lambda is the minimal polynomial of matrix A, implies that m A equal to 0, zero matrix. This is also zero matrix. This is number 6. Therefore, m lambda is the lowest degree monic polynomial that annihilates the matrix A, and H lambda is a monic polynomial that annihilates matrix A. This is number 6, this is number 7, and this is number 8. From 6 and 8 we get that, since we know that minimal polynomial divides that polynomial which annihilates matrix A. Therefore, from 6 and 8 we get m lambda divides h lambda. This is number 9. Subtracting both sides of 7 by m lambda multiply unit matrix, we get m A minus m lambda I equal to zero matrix minus m lambda I, implies that m A minus m lambda I equal to minus m lambda I. Let this is number 10. We may write m A minus m lambda I as follow. m A minus m lambda I equal to a minus lambda I multiply a lambda where A lambda is a suitable matrix whose elements are in the form of polynomials in lambda. This is number 11. Using 11 in 10, we get A minus lambda I A lambda equal to minus M lambda I, multiplying both sides by adjoint of A minus lambda I, we get adjoint of A minus lambda I, here A minus lambda I A lambda equal to minus M lambda adjoint of A minus lambda I and unit matrix. Here adjoint A multiply A means determinant of A, means determinant of here A minus lambda I unit matrix I, then A lambda, right side is minus M lambda adjoint of A minus lambda I multiply unit matrix is adjoint of A minus lambda I, implies that A minus lambda I is minus 1 to the power n g lambda h lambda and I multiply L lambda is L lambda L lambda. This is using 1 and minus M lambda adjoint of A minus lambda I is G lambda multiply B lambda using 1 in left side and 2 in right side, implies that G lambda is a non-zero polynomial. We cancel this. This means minus 1 to the power n h lambda L lambda equal to minus M lambda B lambda, since G lambda not equal to 0 and we cancel this from both sides. This is number 11. From 11 we get that H lambda left side divides each element of M lambda B lambda, but we know that elements of B lambda have no factor in common means elements of B lambda have no factor in common. That means H lambda divides M lambda, implies that H lambda divides M lambda. This is number 12. From 9 and 12 we get, in 9 we have seen that M lambda divides H lambda, and in 12 H lambda divides M lambda. That means H lambda equal to M lambda. This is number 13. From 1 we get that H lambda equal to minus 1 to the power n multiply 1 by G lambda, determinant of A minus lambda I. This is number 14. Using 13 in 14 we get, in place of H lambda we write M lambda. M lambda equal to minus 1 to the power n by G lambda multiply determinant of A minus lambda I. This equal to minus 1 to the power n determinant of A minus lambda I divided by G lambda. Proved. M lambda be the minimal polynomial, implies that minimal polynomial of A, matrix A equal to minus 1 to the power n determinant of A minus lambda I by G lambda. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.